All right, so 2.7, graphs of rational functions. Objective, fairly straightforward. We're graphing rational functions today. Vertical asymptotes. So we have already kind of looked at what they are. We're going to get more information now. So go ahead and write down all three bullet points, and then we'll discuss. All right, so vertical asymptotes, as we saw from that warm-up, are where our function is undefined. As we saw, the graph kind of shoots off to infinity because at that point, at that x value, we can't have any point on the function because, well, it makes it undefined if we plug it in. So we find the vertical asymptotes by setting the denominator equal to 0. So we kind of saw that last one from the warm-up, 1 over x minus 7. Vertical asymptote was 7. X minus 7 equals 0. We solve. Okay. It's very important to know that vertical asymptotes are very, very strict. There can never, ever be a point on the vertical asymptote. Ever. Okay? It's never going to cross a vertical asymptote. Once you set up that vertical asymptote, your graph is not going to cross it. So if it was a quiz or a test or something like that, if I saw your graph kind of going over that vertical asymptote and coming back or doing some stuff like that, I'd automatically, just by glancing at it, I would know something went wrong someplace, because our graph should never cross our vertical asymptotes. Okay? All right, so horizontal asymptotes. The horizontal is the horizontal line. So again, we saw in the warm-up, the slide 2, I had that dotted out. Is the horizontal line that the function will not cross most of the time. It's not as strict as our vertical asymptotes. There can be points on the horizontal asymptotes. It's just most of the time it will not cross. It's only going to cross maybe once, maybe twice. But other than that, there will be no other points on the horizontal asymptote. So just real quick, an instance where there will be a point on the vertical asymptote. So here's my x and y. Say I have two vertical asymptotes. And that can occur if we have a quadratic in the denominator. So we would have two solutions for the denominator. So if I have two vertical asymptotes and I have a horizontal asymptote, let's say it's a little bit above the x-axis, and let's say my graph kind of comes down as we saw on some of those and comes down on the other side, there is going to be something in the middle. Now sometimes the middle is just a parabola, doesn't cross, but other times it does kind of like a cubic function in the middle. And if that occurs, there is a point on the vertical asymptote. And so usually the only time that we cross the horizontal asymptote usually is when we have two vertical asymptotes. Now there are other times other things happen. So the rule is that usually we don't have anything on the vertical or horizontal asymptote, but there are times that it could occur. However, vertical asymptotes, very strict, never ever a point on those. It's the horizontal asymptotes that you might. Okay, it just depends on the problem. Every problem is different. Okay, though the process that you do it will be the same. All right, finding the horizontal asymptote. Now this theorem, it's a horizontal asymptote theorem, is on the paper that I gave you. Okay, so if you would like to copy it down into your notes, you can. Or if later on you want to get a pair of scissors and glue and cut this out and put it in your notes, you can do that. Or just put this, I already 3-0 punched it, you can put it straight in your notes as well. So this slide and the next slide are already on this piece of paper, so I'm going to go through it a little bit more quickly. I am going to put examples for each of these three cases. They're cases. They are not steps for this part. Okay? 1, 2, and 3 here are cases. They're if this, and that's what you do. If this is what you have, then that's what you do. Okay? So for the horizontal asymptote, the way that we find it is we look at the first term in the numerator and the first term in the denominator. That's why I only have that, and the rest is kind of dotted out because we don't really care what the rest is for the horizontal asymptote. Now we care what it is for when we do the final graph, but for the horizontal asymptote, that's what we're looking at. So what we're looking at is our degrees, our powers of the numerator and the power of the denominator. So if the power of the numerator is less than the power of the denominator, so the power on the top is less than the power on the bottom, then a horizontal asymptote is automatically just x equals 0, which is our x-axis. That is what we had on each of the problems in the warm-up. All of those fit in case number 1. Okay? Another example where that would be is if I had f of x equal to, let's say, x plus 2 over x squared minus 4. I look at my powers. The power in the numerator is a 1. Power in the denominator is a 2. Since 1 is less than 2, my horizontal asymptote is y equals 0. Okay? Case number 2. If the powers match, if they are the same, then the horizontal asymptote is going to be the ratio of the leading coefficients, a over b, which you see the a and the b up in there. Okay? So another example of what that could look like is if I had, let's change that first example to x plus 2 over just x minus 4 instead of x squared. If that's what I had, what's the power in the numerator? For that second example, what's my power in the numerator? 1. If I don't see it, it's a power of 1. What's my power in the denominator? 1. Since 1 equals 1, not 1 equals 0, 1 equals 1, then my horizontal asymptote is going to be the ratio of the first numbers. Now that's going to be 1 over 1. Okay? So it's whatever I have there. So if I change that from 1s and I made that maybe 3 and 5 out front, then my horizontal asymptote would be 3 over 5, 3/5. It's just whatever my leading coefficient is, I take that as a fraction. If I can reduce it, that would be my horizontal asymptote. Okay? Case number 3. If the numerator, the power in the numerator, so the top power, is greater than the bottom power, the power of the denominator, then there is no horizontal asymptote. We actually have what's called an oblique asymptote, but we're not dealing with that in this class, so just there's no horizontal asymptote. Okay? So a quick example of what that could look like. I'm just going to take the first example and flip it. So we have x squared minus 4 over maybe x plus 2. All right. We see our top power is 2, bottom power is 1. 2 is greater than 1, so we have no horizontal asymptote. Okay? So we're going by the powers. That's what you look at first. Only case number 2 deals with the leading coefficient. The rest of it is either the x-axis or no horizontal asymptote. All right? So that's how we find our horizontal asymptotes. So, guidelines to graphing. We have step number 1 is factor. I would make it maybe a little amendment to that we're going to factor both numerator and denominator. Okay? So, that's if you can. If you can't factor, then you can't factor and you skip step 1. Step 2, you're going to find the y-intercept. That's where you let x equals 0 and solve. In the previous times, we said that's when we do f of 0. It's the same thing. Okay? Find the x-intercepts. That's where we set y equal to 0 and solve. But all you really need to do is just take the denominator and set it equal to 0. Find the zeros of the denominator. So we're going to take this, set equal to 0, and solve. Okay. Step 4, we'll find the vertical asymptotes. That's finding the zeros of the denominator. So same way, take the denominator, set it equal to 0, and solve. Next, we find the horizontal asymptotes, and that's the chart or the steps or guidelines from the previous slide, what we just looked at. And then step 6, you just need to get some more points to make an x and y chart. But be smart about it. Use your vertical asymptote as a guide of what points you should probably pick. And then connect with a smooth curve, and you'll be done. All right, so let's go ahead and do one. So put that one in your notes, please. All right, so step number 1, can we factor the numerator? It's just 3. Can I factor that? Can I factor the denominator? So step 1 we're not doing. Step 2, find the y-intercept. So what are we doing? Let x equal 0, so f is 0. So I'm going to actually put that this step is for our y-intercepts. So f of 0 is 3 over 0 minus 2, so we have negative 3 halves. So the point 0 comma negative 1.5. So I'm going to go ahead and plot that on my graph. There we go. Step 3, find my x-intercepts. What am I going to do to find my x-intercepts? What did we just say in the parentheses? What am I setting equal to 0? The numerator or the denominator for the x-intercepts? Numerator for x-intercepts, denominator for vertical asymptote. Okay, so my numerator is 3. Does 3 equal 0? So do I have any x-intercepts? So I have no x-intercepts. So what do you think is my horizontal asymptote then? Any thoughts? Yeah. No. So if I have no x-intercepts, would my graph ever cross the x-axis? Probably not. So if I'm never crossing the x-axis, what's probably my horizontal asymptote? Y equals 0. And we'll see that when we get to that point, okay? Step number 4, vertical asymptote. So VA, that's how I shorten it. Okay, I don't like writing out vertical asymptote or horizontal asymptote. I shorten it. Okay, what am I going to do to find the vertical asymptote? This is when we set the denominator, x minus 2 equal to 0. So my vertical asymptote is x equals 2. So I go over to positive 2. It's a vertical line, dotted, straight up and down. I cannot cross this line. Okay? All right, step 5. Horizontal asymptote. That's where we use our chart. Let's look at the powers. What's my power of the variable in the numerator? It's not a trick question, by the way. If I put it, what would my power be? 0. If I don't see a variable, your power is 0. Okay? What's the power in the denominator? Okay, so 0 is less than 1. That matches case number 1. So, as we guess, the horizontal asymptote is indeed y equals 0. Okay? So, x-axis, dotted line going horizontally. y equals 0. That is my horizontal asymptote. All right, what's step 6? Make an X and Y chart. Let's be smart about it, though. I need points on both sides of my vertical asymptote. I already have 0 and negative 1.5. I already have that. What other points? I should probably get 2 more points on the left of my vertical asymptote. So what other points might I want to get? I do negative 1. Definitely. What else? I already have 0. That was my y-intercept. What else? What's between 0 and 2? I'd probably do 1. Okay? I wouldn't go much further away from my vertical asymptote than that. All right, let's go on the other side. What x values can I pick for the other side? Let's get 3. I had 3 on the left, 3 on the right. What should I do? X equals... So my vertical asymptote is at 2. I'm not going to pick 2 because that's not going to work. But I need to go to the right of 2. What numbers are to the right of 2? It's an easy question. So pick 3. What else? And maybe 1 more. So 3, 4, and 5. If you want to go decimals, you can totally go decimals if you want. I tend to like to work with whole numbers. All right, so plug them in. So I have 3 over negative 1 minus 2 would be 3 over negative 3. So negative 1, negative 1. 3 over 1 minus 2 would be 3 over negative 1. So 1 and negative 3. I'm going to let you guys do the other 3. Okay? I'm going to plot the points I just found. And I'm going to connect them with the curve. Remember, I cannot cross my asymptotes. Okay? And so that one side should look something like that. I know from the ones that we saw in the warm-up, it's going to come alongside the asymptotes. And so you'd do something like that. Okay? All right, so go ahead and do the other 3 points. Get the other side of your graph. And finish that one up. We got 3. Okay, so 3 and 3. What did we get for x equals 4? 1.5. Okay. And x equals 5. And so again, just like the other side, we come down from alongside the horizontal vertical asymptote. We go through our points. My graph, I don't have enough room, but it would then go alongside the horizontal asymptote. Okay? And that's how that graph would look.